When we have some functions, sometimes we want to evaluate what happens to those functions at very particular points in time. So I have a function, a quadratic, f of x equals x squared plus 3x plus 5, and I want to evaluate it at 2, or f of x plus 3, or f of minus x. So let's see what happens when we do that. The basic game plan here is this value I'm going to substitute in everywhere I see an x. So f of x, but I want to evaluate it at 2. So everywhere there's an x, I'm going to place a 2 instead. So I have a 2 squared plus a 3 times a 2 plus a 5. Now, I'm putting these parentheses here just to make sure I be very careful. So let's go ahead and evaluate this function. 4 plus 6 plus 5, it looks like f of 2 equals 15. Or this function evaluated at 2 produces a 15. Let's look at the second component to this function. I want to evaluate it at f of x plus 3. So instead of an x, it's going to be an x plus a 3 equals, and everywhere I see an x, I'm going to put in its place an x plus a 3. X plus 3 squared plus 3, x plus 3 plus 5. Now notice I did this on purpose, that I did not put parentheses around it, and I hope you can see why. First mistake is, it's just going to be a 3 squared. Well, really, it should be the entire x plus 3 squared. And likewise over here, it's 3 times the entire x plus 3 and plus 5. So therefore, you see why it's so important to maintain some parentheses when we're evaluating some functions. Let's continue. X plus 3 squared, we have to remember how to factor that. So that's x squared plus, what is that, guys? 3x plus 3x, 6x plus 9. Plus 3 times x. 3 times 3 is a 9, plus a 5. I can remove those parentheses since they're not causing anything to happen. Now I want to go ahead and gather like terms. I only have one x squared, so I have an x squared. I'll look for all my x's. 6x plus the 3x gives me a 9x. 9 plus 9 plus 5. That gives me 18 plus 5 is plus 23. So this function evaluated at x plus 3, or f of x plus 3, produces the equation, or the quadratic x squared plus 9x plus 23. Lastly, let's evaluate this function at negative x. And again, I want to make sure I put in or substitute negative x everywhere I see an x. So it's negative x. I got to maintain that parenthesis right here because I want to square the entire term, not just part of it. Plus 3 times negative x plus 5. Go ahead and do some order of operations in algebra. Negative x squared produces an x squared. Plus 3 times negative x produces a negative 3x plus a 5. There are no more terms to gather, no more like terms, so there's my conclusion. F of negative x produces x squared minus 3x plus 5.